Hello everyone. Today we will discuss about the electric field due to a dipole at a point on its axis. I have already discussed that a point on its axis is also called as axial line or end-on position, right? So any point on the axis we can calculate the electric field. We are deriving the formula for that. I have drawn the diagram, basic diagram which you already know, that equal and opposite charges separated by some distance is called an electric dipole, which I have already drawn. This is the center of the dipole. So this distance will be A and this will also be A. I have to take a point on its axis. So suppose I am taking the point here on its axial line. This is point P where I have to find the electric field, right? So I will extend this line and what do we do to find the electric field at any point? Do you remember? For finding electric field at any point, we place a +1 charge over there. Why do we place a +1 charge? Because we know that electric field is the force acting per unit charge. So that's why we have to place a +1 charge over here. That's for our reference, right? Now what is the second step? We have to mark the directions of the electric field due to both the charges separately at this point P. So let's check out what will be the direction of electric field due to +Q charge at this point. This charge will try to repel it. So what will be the direction of the electric field? The direction of the electric field will be this way. So we can say that this is the electric field due to +Q charge. Now this second charge, which is -Q charge, will try to attract it or repel it. These are unlike, so this will attract it. So the direction of the electric field due to this charge will be this way. This is the second step, which is very, very important. We also need to mention the direction of this dipole, because we will be deriving the expression in terms of the direction of the dipole, that is dipole moment direction, and that direction we all know is given like this. It is directed from -Q to +Q. So this is the direction. If I am writing the direction only, I'll mention it with a unit vector, that is cap, right? Now we have to find the net electric field at point P. So again, the vectors concept, that net electric field at point P will be the vector sum of the electric field due to +Q charge plus electric field due to -Q charge. Again, recall the concept. Whenever we write a vector, we write its magnitude and direction both. So I have mentioned this expression in the form of vector. So what will I do? I'll write the magnitude of electric field due to +Q charge and its direction. What is the direction of E plus Q? If I am considering writing the direction in terms of P cap, which we always do in case of a dipole, we already have a specific direction for a dipole. So we'll mention all the directions with respect to the direction of the dipole. So we know that here electric field due to +Q charge is along the P cap vector. So I will mention the direction of electric field due to +Q as P cap plus magnitude of electric field due to -Q and the direction of the electric field due to -Q. If this is P cap direction, so obviously the opposite direction will be -P cap, right? So this is how we write here. Now let's find out the magnitude of E plus Q. We will write the magnitude separately. So the magnitude of E plus Q. We have already considered the sign or the polarity of the dipole while marking the directions. So for magnitude, we will not consider the sign of the charge, right? So E due to plus Q charge, the magnitude we are writing, so this will be K Q upon separation between that point and the charge. So what is the separation between the point P and charge Q? This separation. Let's check out how much it is. If we mark the separation of point P and the center O as R, then what will be the separation between this and this? Check out. If this is R, if this is R and this is A, what will be this separation? This separation will be R minus A. So this separation is this total minus this gives you this separation. So this separation is R minus A. I hope this is clear. This complete is R. This is A because we have taken the distance of the point from the center of the dipole as R. So this will be R minus A whole square, right? Similarly, I can write magnitude of E minus Q. I have to write the magnitude only. I told you we are not going to take the polarity here because we have taken the polarity to mark the directions of the electric field. So this will be K Q upon separation between this charge and the point P. So separation between this charge and point P will be this and this. So this complete is, this is A and this is R. So this is R plus A. So I'll just draw this, that this is the center of the dipole. This is minus Q charge, this is plus Q charge, and this point is P, which is at distance R from the center, and this separation is A between the center and the minus Q charge. So this complete separation between the minus Q charge and the point P will be R plus A. So here it will be R plus A whole square. I would like to mention this as a line also because sometimes the students get confused. So this is R minus A is the separation between plus Q charge and point P where electric field is calculated, and R plus A is the separation between minus Q charge and point P, which is clear from these small diagrams also, right? So this is the required expression which we will put in the formula which we have obtained here. So this is first and this is second equation I am marking, and this is third equation, right? So from second and third in 1, from second and third in 1, what will I get? I'll get E net at point P is equal to E due to plus Q is K, will replace K in the last step. This is R minus A whole square. This is the magnitude of E plus Q, and I am writing the direction by a different color. This is P cap plus E minus Q is K Q upon R plus A whole square. Direction again I am writing with a different color, which is minus P cap. I can take P cap and K common from this. So the next step will be K common and P cap also common. So I will write inside. Q can also be taken common. So I have taken Q also common. This will be 1 upon R minus A whole square, and this minus will remain inside the bracket. So this will be 1 upon R plus A whole square. Now simple mathematical calculation is required here. So this is E net at P. So this will be E net at P, and K Q, I can write it like this, R minus A whole square into R plus A whole square. I can write it like this if I am taking the LCM. Right? And this will come here. So this will be R plus A whole square minus R minus A whole square. I hope there is no problem in this step. So this will be E net at P. This will be K Q. I can open this bracket, A square plus B square plus 2AB. Right? You know the formula, A plus B whole square. And you know the formula for A minus B whole square also, A square plus B square minus 2AB. Right? And outside the bracket, this is P cap. And in the denominator, I can group together this part and this part. A minus B into A plus B will give me A square minus B square. Similarly, A minus B into A plus B. I am grouping this now, this with this. So this will be again A square minus B square. So what will be the next step? I can write square of this term in the denominator. So this is K Q up, and here this I am not cancelling directly, I am increasing one step to minimize the chances of mistake. Right? Once you are habitual, you will be able to write it directly. Right? And in the denominator, this will be R square minus A square to the power 2. Right? So this is A. Make sure that you are writing a different A. Sometimes when in hurry, you can you get confused between A and Q. Right? So be careful. This will be cancelled, this will be cancelled, this will be cancelled, and this will be cancelled. So you will get this E net at P. You will get it like this. This is K Q into this is 2RA 2RA. So that means 4 times of RA upon R square minus A square to the power 2. This can also be written as K Q into 2A into 2R upon R square minus A square to the power square. And this term Q into 2A can be replaced by the dipole moment, that is P. So I can write E net at P is K P into 2R upon R square minus A square to the power 2. Right? So if I apply the condition that R is very greater than A. Or you can say that the distance of this point is very, very greater than the size of the dipole, right? So we can apply this case if R is very greater than A, or you can say the point P is very far as compared to size of dipole. Then neglect A. I would like to rub the board before writing the last expression. So I'll just rub it and then I'll write the last expression. So that means we are writing the case if R is very greater than A. So what will be our formula? E net at P is equal to K P into 2R upon R square to the power square, because we have to neglect A. So this will be K P 2R upon R to the power 4. So this cancels one power. So this gives me E net at a point on axis of dipole. This is equal to K into 2P upon R cube. And where is our direction? I forgot to mention the direction from this step onwards. So this is P cap. And this is also P cap here, which is giving you the direction of the electric field due to this dipole at a point on its axis. This can also be written as E axis is equal to 1 by 4 pi epsilon naught, if this is in air, 2p upon r cube, and this is P cap, right? So this is all about the electric field due to a dipole at a point on its axis. Hope you understood. That's all for now. Have a nice day.